Okay, question 5 here. So 36-volt battery made using individual cells. So loads of people got this. They realized that, what do I need to multiply? So 1.2 times some number, let's call it n for number, equals 36. So rearrange, make n the subject. So n is 36 over 1.2, which comes out to 30. What we're missing here, though, is that we need 30 cells in series. And I think most people realize this, but they just didn't write it. So you've got 1 cell, 2 cell, 3 cells. So these three would have a, what would that be? 3.6 volts altogether there. And we're going to keep going up until 36. They need to be in series with each other, right? We don't want to wire the cells in parallel like this. And I'm sure no one was even thinking about wiring them in parallel, but we need to show it. We need to make sure that the examiner knows what we're doing. Okay, direct current, very quick. So constant direction. We already talked about this in question 4, so I won't spend long on that. Okay, a calculation. These are my favorites. Write down what we know. Right, so current is 5 amps. We've got a time of 2 hours. Okay, so 2 times 60 is 120 minutes. But I guess minutes is no good, so times by 60 again to get seconds. So 7,200 seconds. Okay, now we've got some proper physics units. We've got 5 amps, 7,200 seconds. Find charge. Okay, so we've got I, we've got T, we need Q. Q is unknown, that's the charge. Okay, Q equals I times T. So 5 times 7,200. 36,000, wow, it's a big number, isn't it? 36,000, and it asks us to give the unit as well, coulombs. This is coulombs, the unit for charge. Okay, find the maximum kinetic energy of the bicycle when the rider is not pedaling. So this is kind of said in the question, when powered only by the electric motor. 90 kilo rider, and the bike has a mass of 30 kilos. Okay, so let's write that out first. So the mass total is 90 plus 30. So that's 120 kilos. Maximum speed is given 6. Okay, so V equals 6 meters per second. I'm asked to find kinetic energy. Okay, so let's write down the equation for kinetic energy and see if we're good. Ke equals half mv squared. Yeah, I've got m, I've got v, so we're good. So a half times 120 times 6 squared. And this gives me 0.5 times 120 times 6 squared, 2160. Check for significant figures. It doesn't say anything. I don't think it's important. We can fit bags on our bike. What effect would this have on the distance? Okay, so it would reduce the distance travelled before recharging. Why is that? Well, you're going to need to use more energy, aren't you, to move the bike? So there's a few ways that you could argue this. You could say that you need, the battery needs to supply more current. And why does it need to produce more current? Well, because you need more energy to move the bike, don't you? You need to supply more current as we need more energy to move bike at same speed. So if you think about this, we just worked out the kinetic energy. There's kind of a reason for that. K equals half mv squared. So again, think about the numbers. If m has gone up, then and the velocity stayed the same, the kinetic energy you need must have gone up. So you've got to put more energy into the bike to get it moving at that speed. You could also have mentioned like drag, air resistance. If the bags are on the side, there's going to be more air resistance. Okay, that's the end of the test, smiley face. This is in your OneNote in P5 in the content library with my annotations on it and the mark scheme below it. Okay, well done.